Hello everyone, this is Dr. Shubha Bhargav from Department of Civil Engineering, SIRT Bhopal. In the series of our lecture, today we are going to discuss the topic physical properties of mineral. In this topic, our learning objective is to understand how these minerals are formed and how can we identify different mineral on the basis of their physical properties. Okay, so let us discuss what is mineral and rock. So mineral is a homogeneous substance which is having definite chemical composition and atomic structure and formed by the inorganic processes. Let us discuss rocks also. Rocks are the aggregate of minerals. So minerals are not found in nature. Hematite is a ore of iron. So always hematite is formed. So hematite having, when we extract during the extracting process, the iron will be separated from the main ore. So ore containing pure mineral as well as some gangue mineral or impurities with them. So when we ores are going through extraction process, so extraction process, we will get pure ore afterward. So we will separate iron from the hematite, and during this process impurities will be separated out. Then what is rock? Rock is an aggregate of mineral. Okay, so it is found in earth crust, and different type of rocks are found. For example, igneous, sedimentary and metamorphic. Igneous, granite is an igneous rock, and granite is composed of quartz and feldspar, and some iron containing iron ores, and some other minerals are also present, but they are found in very minute quantity, but major content is quartz and feldspar. So granite is igneous rock, likewise sandstone and gneiss, schist, marble, all are the example of different type of rock, and they all are considered as a rock because they are aggregate of rock. Some monomineralic rocks are also found in the earth crust, like dunite is a monomineralic rock. Okay, so here we also discussed some crystal. Crystal is a solid geometric figure with well-defined faces which bound the solid. The fundamental characteristic of crystal is regular internal atomic structure and typical external form with mere expression of its internal structure. Okay, so now we will discuss mineral in detail. Mineral is defined as a naturally occurring homogeneous substance which is having definite chemical composition and atomic structure and formed by the inorganic processes. Right. So mineral have been categorized into two parts: rock forming mineral and ore forming mineral. Rock forming mineral are those type of mineral which are formed in abundance, like quartz. You can see sandstone mainly composed of quartz. It is found in abundance on the earth crust. On the other hand, ore forming mineral are those type of minerals which are having high economic value and found in less quantity in the earth crust, because due to they are found in less quantity, that's why they are having high economic value. Okay, so we have categorized like copper, iron, These are the ore forming mineral, and quartz are the rock forming mineral. Now you can see it is a sample of quartz. This is a crystal of quartz. That's why we have discussed crystal part. Crystal is according to crystal system, they are crystallized in their crystal system. So when the at the time of formation, some which type of identical conditions are required for a mineral. If these type of conditions are occurred, so this type of identical piece of mineral or identical type of crystals are formed. Okay, now let us discuss some physical properties by which we can recognize the mineral in field. Okay, when we are in field, we don't have any equipment, any type of solution, and any type of laboratories in the field. So on the basis of physical properties, you have to be able to examine the mineral and identify it. So those type of physical properties should be analyzed, and should be a person or a geologist or a civil engineer should be able to identify the mineral in the field. Okay, so let us discuss some physical properties. First is the color. You know that color is a property. It is light dependent property, and it is appearance of particular object in a light. Okay, a particular color is produced by the reflection of some and absorption of other component of the white light. Okay, a mineral shows color of that wavelength of the white light which is not absorbed by it by virtue of its composition and atomic structure. Okay, so there is three type of mainly colors: isochromatic, oilochromatic, and pseudochromatic. And some minerals are also having some their own color, like this in this picture. This is yellowish color. Every mineral has its own independent different color. Okay, so some mineral showing play of color when it is developed of the series of prismatic color shown by the some mineral on the turning about it in light. And likewise example, diamond show play of color. Then change of color is also shown by the mineral like labradorite. It is a similarly to play color, except that the rate of change of color on the rotation and their intensity is rather low. Each color continuous over a large space in a mineral before the other take over. This property, change of color, is shown by the mineral labradorite. Okay, so in this picture you can see in this picture a natural color of this particular mineral is shown. So always when we go in the field, some minerals are not found in their original color because they are having some impurities. So approximately we can analyze and we can evaluate on the basis of their color. So let us discuss first some properties. There is some physical properties. First one is color, then streak, luster, form, cleavage, fracture, hardness, specific gravity, definity, and the name of the. On the basis of last property is the name of mineral. Why we place here? Because on the basis of these properties we have analyzed that this mineral is this. Okay, so this last property is The name of mineral is placed here. Okay. Now discuss. We have discussed color. Now streak. What is a streak? Streak. The color of a mineral powder is known as a streak. How can we determine it? There is some plate known as streak plate. It is formed by or it is prepared by the porcelain, and all laboratory having streak plate. When we rub the mineral on the streak plate, the powder is on the streak plate. The color of that powder is known as a streak. Only some mineral giving different streak. Most of the minerals always give white or colorless streak, but in case of hematite, it always give cherry red streak. When you see the hematite, it is looking light reddish black, but it always gives cherry red streak. So it is a very identification property, very good identification property. By this, you can recognize in field. The mineral can be recognized in field. Then luster. Luster. What is luster? Luster, reflectivity of a mineral in the independent light. Reflectivity. When we reflect the sample in the light, it reflects the light like different objects. Suppose first is adamantine. Adamantine, when mineral has a luster like diamond, it is brilliant type of bright luster. Example is zircon. Resinous, when a mineral having luster like grease, dull with some shine. Example is opal. Vitreous, when mineral having luster like glass. Most of the your sanitary wares having vitreous luster like quartz. Pearly, when mineral having luster like pearl. Example, talc. Talc is a mineral which is used for the preparation of talcum powder. Its hardness is very low, one hardness. It is very soft mineral. Okay, its luster is pearly. Then metallic. All metals will give metallic luster. Like galena, having splendid metallic luster. Silky luster, like silk, shine of silk. Asbestos always give silky luster. Then dull, just like earthy, luster like soil, earthy. That is known as earthy luster or dull luster, shown by the bauxite. So this is different luster of different type of minerals. It is rosy quartz, is a netherite, some piece of cutted diamond. Okay. Now, next property is our form. Form. Mineral assume different shapes which depend upon the internal structure of mineral. Different terms are used for different type of forms. Okay. Foliated. Folia means when some fibrous or some layers can be separated. Simple sheets can be separated. So the example is mica. Mica having two variety. Black mica is biotite. White mica is muscovite. So both the micas containing foliated luster. The layer or the paper-like form is, or the layers are separated by the main body of the mica. Radiating. Radiating means when the light is radiating from center to different direction. When a fiber or a needle like arranged in a central point, radiating, that is known as radiating form. Iron mostly appears in this. Tabular, the mineral is flat rather than elongated. Orthoclase always give the tabular form. Rainiform, rainiform, when mineral possesses round, kidney-like shape, somewhat round kidney-like shape, so it is considered rainiform. And example is hematite. Fibrous, like asbestos. Fibrous, just to see, this is like just like a fibers, or aggregate of fibers. Fibrous form, asbestos shown by the fibrous form. Columnar, just like a pillar, column. Hornblende always found in this category. Granular, chromite, just aggregate of sand. When you hold the sand in your hands, like which this type of appearance is known as the granular appearance, and chromite give the granular appearance. Crystalline, just like a crystal. You have number of times you see that. Bladed, bladed, when mineral appears like blade, like armature, it is just look like a armature when number of blades are hold in a thick manner. When acicular means aggregate of needles, when number of needles are collected in the hand, or the aggregate like structure, then it is known as acicular form. Natrolite always give acicular form. So so many different type of forms are found in the nature. These all are the form. These are the crystals. Just this is the acicular form. You can see here. Okay, this is the flat tabular form. Cleavage. Now we will discuss the cleavage. Cleavage. What is cleavage? Cleavage is the tendency of a mineral to split along the parallel planes, producing more or less a smooth surface. Cleavage lines are the weak lines or the divisional planes in minerals. So we have categorized the cleavage into two categories: perfect or good distinct. When mineral does not split with great or the great ease, or gives some smooth surfaces, then like mica and feldspar, these all are the soft mineral. Mica is having hardness to 322, and feldspar having hardness 6. So when they split, they are not easily split. Okay, and the imperfect means when mineral does not split with the average force. Okay, quartz is example of cleavage. Okay, so it is also categorized in this in one direction. When the mineral is split in one direction, then it is said one set. When it will split into two direction, then it is considered as a two set of cleavage. Example, feldspar. And three set is halides, and calcite are also having three sets of cleavage. Okay, I think this much is enough. We will continue in next class. Thank you, everyone. We will brush up these properties first, and afterward we will discuss the further properties. Okay, thank you.